Hello, party people. People who love to party. It's me, Mr. Bill. And today we're going to be talking about transversals. Yes. Come and take a trip with me. Hopefully you have downloaded any of the materials that you need, or at least have a separate piece of paper with you so that you can work along with me. Remember, guys, just watching the video is not enough. It's not learning. All right. So the first thing you are going to do, and this is going to be a little bit different today. We actually have a notes component of this. We'll see how that works. Transversals says solve the system of equations by graphing, underlined. That's what I want, and list the point of intersection, because that's how you solve by graphing anyway. You have to list that point out. So please graph those two lines up. I will do the same. You could pause it and graph them, or if you think you're just faster than me because I'm an old man and I'm slow, maybe you're just going to do it while I talk. You'll listen to me like, some sort of humming refrigerator in the background as I slowly put together these beautiful lines. I like making a whole lot of dots too. I don't know about you guys, but hopefully it crosses at one of these nice dots. I'd like to have it already on the graph. That would be ideal. So there's my first line. Y is equal to 3x minus 8. Y equals 3x minus 8. Is that line? Okay, and then I need y is equal to negative 1/2 x plus 6. So that's way up here. 1, 2, 3, 4, 5, 6. Down 1 over 2. Down 1 over 2. We found it. Yay. And then we throw a line through that bad boy. Nice. There we go. Looks like their point of intersection is at 1, 2, 3, 4, 1, 2, 3, 4. 4, 4. Ding. Now, why did I have you do that? I thought we were supposed to be doing geometry stuff. We are. Next part says measure one of the angles formed by the two lines, then calculate the rest. All you should need to do is measure one of those angles because of the vertical angles lesson that we did the other day. Right? Go ahead and measure them with your protractor. Mr. Bill, I don't have a protractor. Yikes. I don't know what to tell you. Watch me measure them then, I guess. I'm going to turn my paper all around squiggle-wise. This is heck of splonty right now. Ooh, I need my lines to be longer. Just happens like that. Sometimes, guys, don't be afraid to make your line longer. Although I, like you, don't like to have to do that. Wish I'd done it right the first time. Looks like I'm going to get around, let's see, counting this way, we get to 90. No. Counting this way, we would go that way. So it would be 90, like I just said. Past 95, 96, 97, 98. 98 degrees. Now what I've told you to do is calculate the rest. Rather than measure the rest, calculate them because of the special ways that these lines work. Oops, I forgot to name this line. Y is equal to negative 1/2 x plus 6. So if this was 98, this has got to be, well, forget that one. This one's got to be 98 because they're vertical angles. Now, these two should add up to make 180. So 180 minus 98 should give me that one. Let's see, 17, 10, 2, 82 degrees. Ta-da. There we go. It was the vertical angles thing again. You never even expected it. So go down to the next part. I would like you to solve those by graphing as well. See what happens. I'm waiting for you to do it. Go ahead and do it. Do it now. You. -2, up 1 over 3, up 1 over 3. I know someone just didn't do this. They're just like, I'll just wait him out. He's got to do the problems. You know, you're right because this is a video, but you're wrong because you're messed up in the head. Bam, there's my first line. And then, man, what kind of magic trick am I going to use to do this one? I guess I could graph it with the intercepts. So that'd be x and y, 0 and 0. See, so the first one, if I put in a 0 there, That's 3y is equal to 9, so y's got to equal 3. And if I put in a 0 here, negative x is equal to 9, so x is equal to negative 9. So my 2 points are 0, 3, and negative 9, 0. And that's because of the way I oriented the chart. I know you guys get on me sometimes about the way that I do charts, but back off. 0, 3, ding. Negative 9, 0 is this way. Wait a second. Ding. It's not. No, isn't it? Okay. Oh man, look at the mess we've created here. It says down at the bottom, measure all the angles formed by the lines. Do they even form any angles? No, they're not even touching. There's no vertex for us here with these parallel lines. But a funny thing can happen. If I decide to throw a line in between these two, say we decide that our line is the y-axis. Look how nice it looks right there. Bam! Then a crazy thing happens because I get two sets of identical vertical angles. They're exactly the same because the two lines were parallel. And that's what we're going to take notes on, because that's the big idea right there. And we've got vocabulary involved, which is why I figured that we would need a notes page. So I, on the next page, have colored in these parallel lines. This line and this line are parallel. And there's a line that is touching both of them. And that line that touches both of the parallel lines is called a transversal. Now I've colored all the angles. I hope that you can see the colorfulness of the angles, because these angles right here are the same as these angles right here, and they're in the same spot, but they get particular names. Just like if I were to go up here, you remember these two angles were vertical angles, but if I was side by side, they were adjacent supplementary angles or a linear pair. Depending on where these angles are located here across from each other, they get different names, which is what this thing is all about. So the first thing we're going to put in there is angles. And let's go up top. Let's number these, not only color them. Let's go 1, 2, 3, 4, and 5, 6, 7, 8. So if I want vertical angles, just vertical angles, which angles am I talking about here? Well, if I'm talking about this first part, that would be angle 1 and angle 3, angle 2 and angle 4, because vertical angles come in pairs. Remember, it's two of them together. And then if I move on to this down part right here, I would have angle 5 and angle 7, angle 6 and angle 8. And those are vertical angles. Redraw them. Okay, no problem. All I need for vertical angles whoosh, whoosh, are lines like that. Ding, ding. And vertical angles are congruent. I could do the top ones too. Do you want me to do the two little marks for the top ones and the bottom ones? I know someone said no, I don't care. There we go. Vertical angles, reason. Now, why are they the way that they are? Well, vertical angles, there's a theorem called the vertical angles theorem. It states that they're congruent to each other. So this reason is, we could say by observation. Or if you wanted that super technical term, because you're a super technical person, the vertical angle congruence theorem. Ta-da! And a theorem is something you could prove. So that's super provable. Now we're going to get into something that you can't prove, because when we do all these angles going from this one over to this one, we have to start somewhere with something that we can't prove, but we can agree that it's for sure true. Your book starts in a place I don't think I like, if I remember it correctly. So I start the way that an old book starts, which is with corresponding angles. That's the first one we'll do. So in the type, you're going to write corresponding angles. Like that. And over here, our corresponding angles are in the exact same place in both of the vertical angle sets. So angles that correspond would be 1 and 5, or 2 and 6, because they're in the exact same spot in both of the places. Now, you may be looking at those colors like, oh, so wait, all the colors match up? Yes, that's why I did that. So, for instance, our corresponding angles could be angle 1 and angle, I forgot what I said, 5. Angle 2, and let's see, where's the blue angle? Angle 6. Angle 3, and looks like we're looking for the purple, so that'd be angle 7. And the last one, angle 4 and angle 8. Ta-da! Those are the corresponding angles. Now we need to redraw them. This is where protractor comes in super handy, because this little in-between part should be just enough to fit in there and make you some parallel lines. Now this is oriented a little bit different than the stuff that I have right here. See, mine are going straight. So if I slanted them like that, then it would be the same, and then I draw the line through them. It doesn't matter how slanty they are, though. What matters is that my angles are in the exact same place. So right here and right here, this would be like the upper left and upper left on both of these guys. Those are corresponding angles. Now the reason, we do have a reason for these guys. It is called the corresponding angles postulate. Postulate is something that we just kind of agree on. Oh yeah, that's got to be true. You know, we shake hands, maybe break dance a little bit, and then we walk away. There you go. The next one that we're going to do is we are going to go outside. We're going to go outside of what we've got. And our outside angles look to be 1 and 2 and 8 and 7. And by outside, I mean they're not in between these two parallel lines. See the inside stuff? We are going to the outside stuff. And these outside angles that we're going to do are called alternate exterior angles. And they are on the outside of the parallel lines. And they alternate sides. And that means they change sides. So if I cover up this middle, I'm not trying to think about anything here that's in the middle. I just want to deal with 1 and 2 and 8 and 7. As you even look at them, look, 1 is definitely an acute angle. 7 is an acute angle. So 1 and 7 are the two that are going to be congruent to each other. And 2 and 8 are congruent to each other. Instead of staying on the same side with 1 and 8, they switch sides. So this would be, let's see, alternate interior angles, or exterior. The next one we'll do will be interior. Alternate exterior angles. And the angles this time were just on the outside, 1 and 7. And 2 and 8. I'm then going to redraw them with my protractor. Pew, pew, zoom. So I'm looking for where the inside is. I don't want the inside, I want the outside. So I could take this angle, and then what's the angle over here that's going to match up with that one? On the other side of the transversal. See, this side, flip over to that side. Why? Well, this would be called the alternate, exterior angles theorem. Maybe in your book it's the alternate exterior angles postulate, and then there's a corresponding angles theorem. I don't know. I know it likes to say stuff different than the way I like to say stuff sometimes because I'm stuck in the past. All right. The next set that we're going to do is the angles on the inside. Oh, yeah. Which angles are congruent to each other on the inside? Because this whole time, we've been matching up angles that are congruent to each other. Alternate interior angles. I bet you guys can guess what interior means. On the inside. Inside of what? The parallel of the parallel lines. Have you guys noticed as I write on this thing, like how bad my handwriting is? I have. Oh. And these also alternate sides. So if I close off the outside, what I'm looking at is 3 and 4 and 5 and 6. So which one is 3 going to be congruent to? Well, it's got to be 5. So we're still on the inside. We move down to this one, and then we change sides. And 4 will be congruent to 6. Now, I haven't been writing the symbol for congruent. Angles, let's see, what was that inside? 3 to 5, 4 to 6. Because all of our relationships so far have been congruencies. These were congruent. These guys, congruent. 1's congruent to 5, 2's congruent to 6, 3's congruent to 7. These guys, congruent. Equal sign with a mustache on top, congruent. Alternate interior angles. Let's draw an example for ourselves. Let's see, I need to go inside. So how about this one? And the one that's congruent to this, I'd move up and switch sides. Bam, still on the inside. Reason, well, the reason that we give when we do proofs and stuff, which I'm not gonna be able to teach you proofs over the internet, I don't think, is the alternate interior angles theorem. I'm sure a braver teacher than me will try to teach some proofs over the internet. Remember, I don't teach the best, I teach the most. You're like, well, then why not proofs? How come that can't be part of the most? Get out of my face, kid. Okay, back off. All right, the last set that we're going to do has a couple of different names. The name that I like for it, though, is same side interior angles. There's another word for it, though, called consecutive interior angles, which is even better than same side. But when I say same side, you guys know I'm talking about the same side. Same side interior angles. I lied. I think I like consecutive better, but we'll use same side interior angles. So we're going to the inside, and we want the same side on the interior. So if I'm at 3, I'm going to move over here and not flip over. 3 and 6 are same side interior angles. Same side on the inside. So on the inside, inside of what? Of the parallel lines. Same side. I mean, it's in the name. Same side interior angles, inside, same side. You know what? I don't want to get sassy with you. So when we put this down, before I put it down, the notes part, we're looking at 3 and 6, 4 and 5. 3 and 6, angles 4 and angles 5. So what is their relationship, though? Because you can look at these things, and 3 is not going to be congruent to 6. 3 was congruent to 5. Well, 5 is right next to 6, which means if this is a vertical angle set, I've got a linear pair right there, and these add up to make 180 degrees. Therefore, 3 plus 6 must make 180 degrees. Therefore, these angles aren't congruent. They are supplementary. It's a whole lot of logic I just put on you right there. And remember, supplementary means plus together to equal 180. These were same side interior angles. They looked like this. Now I know what you're thinking, Mr. Beal, you're probably cutting stuff out of teaching us because of the weird format of what's going on. Oh yeah, that's true. There's some stuff it's not gonna work this way. So then why'd you decide to do this? Yeah, that's a good question. Because in IM2, if you're going to IM2 next year, you will need to know this. And IM2 teachers are always telling us about, it seems like you didn't teach the kids this thing. I now have video evidence that I did try to teach you this. And that is how I will get out of the jail time. My lawyer will cite this video. The judge will acquit. The jury will shower me with rose petals. And I'm back, teaching the most. So what are you likely to see with regards to these things? Well, just like with the vertical angles, I can start putting numbers and stuff in here and make you try to figure out how much they are. I could say that this is 3x plus 2. And that this over here was 4x minus 13. If that's the case, then how big is x? For that matter, how big is angle 1 or angle 7? How would we even do that? Well, angle 1 and angle 7, they look to be alternate exterior angles. And alternate exterior angles, according to my notes, are congruent. And congruent things have the same measure. Minus 3x minus 3x. You got 2 is equal to x minus 13 plus 13 plus 13. X is equal to 15. If you remember the lesson from the other day, x was 15 there too. I must really like 15. If I wanted to know how big the angle was, I would just plug that back in. I could plug it back into either of them and get the same thing. So 3 times 15 plus 2, that is 45 plus 2. That is 47 degrees. That's how big this angle is. That's how big that one is. Not only that, that's how big angle 3 has to be. Not only that, that's how big angle 5 has to be. So then how would we find out how big angle 2 is? Well, if we know this is 47, let's say 180 minus 47. That's 133 degrees. 133. And it's everywhere. 47 degrees. 133 degrees. 47 degrees. 133 degrees. 47 degrees. 133 degrees. If you, like me, love the idea of symmetry, things being the same on one side as they are the other, ain't nothing better than transversals and stuff. All right, guys, your work's going to be a little tough because we spent so much time going over the vocabulary in this. So I know when you get to your independent practice, it's going to be a little bit hard, but I can't have these things last too long. So that is the end. And like always, I always tell you this, stay safe out there. The world is crazy.